All right, I want to look at a problem here that is going to be looking at the function of the square root of x. We have f of x equals the square root of x. And what are we going to do with it? We're going to ask ourselves, what's the limit of f of x as x approaches 1? So the limit of f of x, as x approaches 1 of square root of x, which we know equals 1. Now what we want to do is, given a particular epsilon, which our epsilon is going to be 1/3, what's going to be the delta? So with an epsilon of 1/3. So we're going to use our delta epsilon process. We're going to take the square root of x minus 1 is less than epsilon. We'll break this into epsilon positive and negative. We'll, get my epsilon to look like an epsilon, and we'll add 1 to both sides. In fact, I'll make this 1 plus epsilon so that they have the same form. Then we'll square everything. So we'll get 1 minus epsilon squared is less than x, which is less than 1 plus epsilon squared. And then we'll look at our delta side. X minus c, which is 1, is less than delta. We'll look at this for both deltas, both end caps. And so 1 plus delta is less than x, which is 1 minus delta. We'll add 1 to each side. It's less than x, which is less than 1 plus delta. And we'll line these up. We'll say that 1 minus delta, the boundary is equivalent to epsilon squared, or delta, we'll move delta over this way, 1 minus epsilon squared. And doing the other side, where we'll subtract 1 from each side, 1 plus epsilon squared plus 1. And so we need to find the smallest delta. And so if I drop in my 1/3, I get 1 minus 2/3 squared, and 1 plus, let's see, if that's 1/3, that's 4/3 squared. And so this delta here is 1 minus 4/9. So 9/9 minus 4/9 is 5/9. And then this becomes 1 plus 16/9, or 25/9. And so this is our smallest delta. And so this is the largest delta that satisfies this condition, comes from this smallest one, 5/9. It's the largest thing that epsilon can fit into.